Welcome back to another video. Today we're looking at question 34. Find first and last position of element in sorted array. The way we'll be approaching this problem is by creating a method that will look for the index of an element that is equal to or greater than the provided target. So what exactly does this mean? That means that when we give a given target to that particular method, it will give us a first index where we can find an element that is equal to or greater than the target. So when we give the target, we will get the start index of the given target. But for the end index, what we need to do is we need to provide the target to be target plus 1, which means that it will give us the index of the first element that is greater than the target. And once we have that index, we just need to subtract 1 and return it. So this method is a lot easier than trying to implement a binary search, which looks for two indices, one on the left and one on the right. This would mean you would implement just like one binary search that looks for an index that is greater than or equal to the target, and you would just call it twice. Awesome. So let's get started. The first thing that we need to do is actually take care of the test cases. So if nums equals null, or if nums.length equals 0, you would just return an array with the -1, -1 in it, as recommended by the question. And next, we need to implement that method that says first equal or greater. And what does this take? This takes in two parameters. It takes the nums, and then it takes the target. Awesome. So let's initialize the left and the right index as we always do. Int left equals 0, int right equals nums.length. And we also have mid, but we don't really assign anything to it. And then we have a while loop that has left is less than right. And then we assign the mid value. Mid value would be equal to right plus left divided by 2. Awesome. So there are two cases that we need to take care of. If nums of mid, if it is less than the target, we just move the left index. So we say left equals mid plus 1. Else, what do we have? Else, if nums of mid is greater than or equal to the target, this is what we're actually looking for, right? So we would just assign right equals mid. And the reason why we're doing this and not really doing mid -1 as we traditionally do in binary search is because we know that at the right index, after we've assigned it, we know that the target exists, but we want to get the first index of the target, which is less than or equal to the target, which means we still need to keep moving towards the left. So you update the right, but you keep the left as is, and you keep moving to the left. So once you finish the while loop, you would just return the left value, right? And then here, let's say start, and then you would have called this on the target. So you would say nums, and then you would have passed target. And then after you get it back, you need to check, hey, you know what? Is the start, is it equal to nums.length? That means, did we not find the element that we were looking for at all? That means, like here, how we see, we keep assigning left equals to mid plus 1, and then the rightmost value that we actually assign to it is nums.length. So it would actually be nums.length and not nums.length -1. So you're checking, hey, does this element actually exist or not? If it is out of bounds, that means it doesn't exist. And the other thing you need to check is that if nums of start, if it is equal to target or not. If it is not, we know that it hasn't, that the nums array does not have the target at all. So we just return the default array again. Right. So we have, if these two cases, if nothing has been returned so far, we know that we have the start, but we need to look at the left. So how do we do that? So we do int end, we call it again, right? But we call it on target +1. And why do we do that? We do that because we want to find the first index of the element that is greater than the target, right? But just for us, we would subtract it by 1 because subtracting it by 1 would mean that we are getting back to our target. So this end will return us a value of the index where there's an element that is greater than the target that we're looking for. And then when we subtract 1, we get the end index. So once we have these two values, you would just return it. New int, you assign those two values, start and end, and that's it. Awesome. Let's compile this and see if it's okay. Return line 10, new int. Yeah, I made the same mistake here. Okay, let's try it again. Index out of bounds for length 6, 0. Let me see where I made a mistake. Left equals 0, right equals nums dot length. If the target is greater, you would increment mid. If not, right equals mid, left are okay. So if start is equal to nums dot length, or if nums dot target is not equal nums dot start. Sorry. Okay. Yeah. If we run this again, okay. So the first test case is okay. Everything else is okay as well. Awesome. A bit of a glitch there, but we're still okay. Let's talk about the space and the time complexity. The time complexity of the entire solution is a log n, since we are using binary search right here. And the space complexity of the entire solution is of 1, since we're not using any additional space to store any data. Awesome. So if you have any questions about this problem, please let me know in the comments below. Please don't forget to subscribe and like the video. I would really, really, really appreciate it. It definitely